Okay, so in this video we're going to go over the basic introduction to variation, as understanding what variation means in mathematics. Of course, when you go to a book, a dictionary, of course, you're going to find the meaning or the definition of what variation means. So in this case, we are more interested in what variation means, what it means to us when we are in the field of mathematics. So here's the thing. Without even using any complicated word whatsoever, variation just basically means you're talking about a what? This one word, relationship. Okay, relationship between two or more elements. Okay, so now relationship. So in mathematics, we are going to use x and what? X and y as the two elements that you're talking about. You're trying to find out the relationship between these two. So the relationship between x and y can either be what? Inverse. Okay, can either be inverse or what? Direct. Wow, it rings a bell. What does inverse mean in this case, or what does direct means in this case? So I'll try to drive a bit away from what we are talking about to gain understanding of what we are saying in this case. So let's say we're talking about, let's go to physics or even mathematics at some point. It also helps us to understand this. Let's say we have points, these 2 points, point A and point what? Point B. Point A and point what? Point B. So now, let's say the distance between point A and point B is what? Let's say we have what? 10 meters. We have 10 meters. So now, we are trying to find the speed that is going to take for a vehicle to move from point A to point what? B, or a person to move from point A to point what? Point B. Okay, and let's say we are given the time. Let's say we are given the time and say it takes a person to move from point A to point B, or a vehicle to move from point A to point B. We are given these 2 times. Then we are trying to find the speed in those 2 times that we are given. The first one, we are given what? Let's say we are given 2 seconds. Sorry, we are given 2 seconds. Then the first one given 2 seconds. Then the second one we are given what? We are given 5 seconds. We say it takes a person to move from point A to point B. It takes a person 2 seconds. Then on the other one takes how many seconds? 5 seconds. Then we're trying to find the speed. So we need to say speed is equals to what? Our distance divided by what? Our time. So now the distance that we have is 10 meters. We divide by first this one, our A, which is what? 2 seconds. So it's very important. And here is another point. When you're trying to find whatever you're trying to find, please don't forget to write the units, and it's going to help you to find the final SI units that you are of the quantity that you're finding. So we said 2 into 5, 2 into 10, 2 into 10 is what? Is 5. So you say 5 meters per what? Per seconds. So what we are found to say, when we use 2 seconds, the speed that we find is what? 5 meters per second. Now let's try to use so we say here we found what? Here we have found 5 meters per second. Okay, so now let's try to use the 5 seconds that we have been given as well there. So we are still going to say the same thing. Our speed is equals to what? Our speed is equals to be our distance, which is 10 meters, divided by what? Divide by our time, which is 5 seconds. And what you're going to get is what? 2 meters per what? Per seconds. Okay, so what we have here is this. Here we have 2 meters per what? Per second. So now, what understanding are we able to obtain from this or what picture are we able to get from this for us to understand what variation basically means? We have our distance and our time here. So you have seen to say when we had when we had 2 seconds, the speed that we had was what? 5 meters per second. When we had 5 seconds, the speed that we had was what? 2 meters per second. So we have observed to say when we increased the time from 2 seconds to what? From 2 seconds to what? To 5 seconds. Our speed reduced, because at 2 seconds we had what? 5 meters per second, and at 5 seconds we had what? 2 meters per second. So what this basically means is that our speed our speed is inversely proportional to what? To our time. When the speed, maybe we'll write it in this manner. Let's say we have our speed here and we have our what? Our time. So when our speed decreases, meaning our time has done what? Has increased. Or when our time increases, our speed is going to reduce. And this is the case that we had here. When our time reduces, what happens to our speed? It's going to increase. So from this point we can say speed varies inversely to what? To the time that we have right there. But when talking about distance, it is direct proportional. When you increase the distance, you have increased the time. That is what that means right there. So this is the same this is the same explanation or the understanding that we need for us to answer any question that we can be given that we can be given in math. So we're talking about the relationship between what? X and what? X and Y. So can it be direct, where we say our X varies direct to what? To our Y. So instead of using this, if you want, you can also use what? An equals sign. To make your work simple, you can say this one varies direct to what? To that one. And here we're going to have what? A constant. So this relationship that we have here is what? Is direct. What about the inverse one? We are going to say y is equals to, x is equals to what? We're going to have a constant divided by what? Our y. When our x increases, this one reduces. When this one reduces, that one increases. So this is basically the same concept that if we understand this, then it will be very easy for us to answer any question that we can be given on variation. So now let's go to this question. We have been given to say two variables x and y have corresponding values as shown in the table below. So I've been given the variables x and y. So we have also been given corresponding values. So when you're talking about these two, meaning these two that we have here as x was used to obtain what? To obtain y. This 3 was used to obtain what? The 40. So the a here was used to obtain what? The 104 of the y. So now this is what we are trying to find out, to say, okay, now what's the constant that was being used and what's the formula? Yeah. So we have been going to say these two. So you say given that y varies directly as that one. So meaning what we are saying is this. So you say here we are doing our what? Our working. Okay. So now we have been told to say our y. Okay. We say our y, it varies direct as what? X that plus that. That is what that means right there. And we should keep in mind to say outside here we have a what? We have a constant. So now the first question says for us to understand whether it varies inverse or direct. So if it's direct, then it's in this manner. If it's inverse, could have said what? Y is equals to k divided by what? X squared plus what? Plus 1. Now since we are talking about a direct relationship, then the first expression is what we are using right here. This is our k, meaning our constant. So now the first question says find a constant of variation, the constant of this variation, which is, we're just looking for the value of k. So it's more like we are making our k the subject of the what? Of the formula. And when we make k the subject of the formula, we're going to have k being equals to what? Y divided by what? X squared plus what? Plus 1. So here just dividing both sides by what? X plus 1 divided by x plus what? X squared plus what? Plus 1. That is what that means right there. For us to find the value of what? The value of k, we just make it the subject of the what? The subject of the formula. So we are saying k is equals to what? Our y divided by what? Our x squared plus what? Plus 1. So how do you find the value of k? You can either pick this part here, or you can pick this part, the second one, where we have both x and y being known. You still get the same thing. So we'll try for both. We see if what we are doing here is making sense. So we are going to pick the value of y. Remember to say this is more like we are saying, let's say 2 comma what, comma 20. That's what we have in this case at this part. So meaning our value of y is what? 20. We divide by what? Our value of x is 2 to the power 2 plus what? Plus 1. What we get? We have 20 divided by what? This is 2 power 2 is what? 4 plus 1, that is 5. And what do we get as our final answer? 4 into 20 is how many times? 4 times. 4 times. That's what we get. And let's say let's say we didn't get 2 comma 20. Let's say we got 3 comma what? Comma 40. Let's see if we are still going to find a 4. So we are going to say our value of y is what? 40 divided by 3 to the power 3 plus what? Plus 1. So this is what? 40 divided by what? What do we have here? We have 9 plus what? Plus 1, giving us what? 40 divided by what? A 10. That goes. You're still going to find what? A 4. So basically our value of k we have found to be what? To be 4. So you say our value of k is what? Is 4. We have found the value of the constant. So if I found the value of the constant, meaning it would be very easy for us to find whatever anything else that is what? That we need to find. So the second question is asking us to find the equation connecting y and x. So the equation that is connecting y and x, you can basically just write this same one. Y is equals to what? We are going to have our x squared plus what? Plus the k there. Sorry, not k, but 1 multiplied by the k there. Or if you want, you can just say y is equal. You can expand this. That would be what? Kx squared plus what? We can say kx squared plus k. Still the same thing. Yeah, so that is the equation connecting y and x. So now we go to the last question, C. Say find the values of what? Values of a. So remember to say when we have the value of a is basically the value of a is what? The value of x. So it's more like we are trying to make x the subject to the what? The subject of the formula. That's what we are talking about right there. So in this case, you can either go direct and replace everything that you can replace in this case, then to find the value of that, or you can just from this point you make x the subject of the formula. It's up to you. So we are going to use two methods to make sure to say what we are doing is right. It's more like we can prove our answer in short terms. So our value of y, we have been given 104. Okay, we say is equals to, we are trying to use this one first, 104. Then in the brackets there, I'm going to say x what? X squared, because I don't know the value of x, plus 1. I multiply by the value of k is what? 4. So I can divide both sides by what? By 4 to make my work simple. Make my work simple right there. So what I have is that I have my x squared is equals to what? Okay, we have our x plus 1, rather, let's take it step by step. X plus 1 is equals to 4 into 104 is, we can do this. 4 into 10 is how many times? 2 times, remainder 2. 4 into 20, we know is 5 times. Into 24 is how many times? It's 6 times. So it's 26. So what we have this side is what? 26. So now we can take this one the other side. What you're going to have is x squared is equals to what? 26 minus 5. That would be what? X squared is equals to 25. 25 right there. Then you find the square root of that, meaning our x will be equals to what? 5. Positive or negative what? Positive or negative 5. That's what we're going to find our value of what? As our value of x. So maybe someone might want to argue to say, why you are saying x is equals to positive or negative 5. So are we saying if we say we want to try to find the value of y, then we place a negative y, there is x here, is it going to give us the same thing? Yes, it's going to give us the same thing. Why do we say so? Because if you say positive 5 squared is going to give you 25. Negative 5 squared is still going to give you what? 25. They multiply, the negative sign is going to multiply itself, and that would be a positive, and yeah, that will make our x simple. So in this case, we can say our value of a is what? Is positive or negative what? Negative 5. So in which other way can we also find this again? Which other method can we use? Maybe we can use the expanded form. We see if we're still going to get the same thing. So let's say we found, see our expanded form was what? Y is equals to kx squared plus what? Plus k. So now, when we want to make x a substitute with the formula here, we can say the k is going to go on the other side. We're going to have kx squared is equals to what? Y minus k. Divide both sides by what? By k. What are we going to have? So that goes, meaning we have what? We have x squared being equals to what? Our value of y have been given to be what? Or maybe at this point, we can also introduce the square root or in advance, so that we can do this. That will go and that will go, meaning we are going to remain with what? Our x being equals to what? The square root of what? Square root of square root of y minus k. Divide by what? Divide by k. So we start replacing what? Because we know the value of y and we know the value of k. So our value of y is what? 104 minus our k is what? 4. Divide by what? Divide by our value of k again, which is also 4. So what are we going to get in this case? So that would be what? 100 divide by what? Divide by 4. Divide by 4 right there. So now, okay. So what you are going to have is this. We are going to divide our 4 into what? Our 4 into the 100 right there. So we can say 4 into 10 to make our x simple is basically 2. You're going to remain with a 2. So 4 into 20 is how many times? Is 5. So meaning that is 25, and that will still give you what? Positive or negative what? Negative 5. So basically, it's very easy for us to prove our answers. So that's how you go about answering any question on variation. And if you follow the same steps that we have used on this question and in the basic introduction, then it's going to be very easy for you to answer any question that you can face under variation. Yeah. So that's all in this video. Yeah. Thank you.